Welcome in this class. This session, we are going to discuss about the chain rule for a case whereby a function has two dependent variables and two intermediate variables. So continuation on chain rules. So rule 3, functions with two intermediate variables mediate variables and two independent variables. So let's give a statement. So if W is a function of X and Y, and X is a function of R and S, and Y is also a function of R and S. If all the three functions W, X, and Y have or are differentiable, then W has partial derivatives with respect to R and S given by so we have partial W partial R equals to partial W partial X times partial X partial R plus partial W partial Y times partial Y partial R, and partial W partial S equals to partial W partial X times partial X partial S plus partial W partial Y times partial Y partial S. So this is a statement for the third chain rule, where a function depends on two intermediate variables and two dependent variables. As usual, a branch diagram can help you to remember what you need to do. So let's draw the branch diagram. So the branch diagram or branch diagrams. So we have then we have this, and then we have this, so let's do it properly. Then we have this. So we have this point, this point, this point, and this other point. So this is why I have our W, which is a function of X and Y. And then this way I have the X, this way I have the Y, this way I have the X, this way I have the Y. And here is where I have the R, and here is where I have the S. So as usual, remember this is still the W, f of X, Y. So this R, this is a function, which is the dependent variable. Dependent variable. And here X and Y are the intermediate variables. And R, these are the independent variables, R and S. So because W is depending on X and Y, so this branch will be partial W, partial X. This will be partial W, partial Y. And then because this branch, all these functions are in terms of X and Y, then you write this one as partial X, partial R, this one partial X, partial R. We are writing them as partial derivatives because Y itself is in terms of R and S. This one is in terms of R and S. For this other one, similarly, because W depends on X and Y, so this will be partial W, partial X, partial W, partial Y. This is partial X, partial S, partial Y, partial S. So that now when you bring them together, this one will be partial W, partial X is the same as partial W, partial R. This is the independent variable here is R, not W, not X. So you say partial W, partial R, partial W, partial R would be partial W partial X times partial X partial R plus partial W partial Y times partial, so remember this is Y, partial Y partial R, and then this will be partial W partial Y equals to partial R partial S not Y. The independent variable here is S. So I'll have partial S, partial W, partial X, partial X, partial S, plus partial W, partial Y, partial Y, partial S. So that's what we have. So now we can go and solve the problem that we posed last time. This problem here, that given that Z is given by e raised power X, e raised power X sine of Y, and then X is st squared, Y is partial squared T. So partial Z, partial S by definition, partial S, partial Z, partial S. Let's write the formula now. Partial Z, partial S will be given by partial Z, partial X times partial X, partial S plus partial Y, partial Z, partial Y times partial Y, partial S. This one with respect to partial Z, partial X will give us e raised power X sine of Y. Partial X, partial S, this with respect to S gives us T squared. Partial Z, partial Y, this will give us e raised power X and then cos of Y. Partial Y, partial S will give us 2ST. So where there's X, we replace by ST. Where there's Y, we replace by S squared T. So this will be the same as e raised power S T squared sine of S squared T, and then you multiply by T squared plus 2ST e raised power, where there's X, we put ST squared, and then cosine of, where there's Y, you put S squared T. So that will be the value for that given partial Z, partial S. So the same thing can be written as, so T is common, and then e raised power S T squared. So this would be T sine of S squared T plus 2 cosine of S squared T. So there's an S here. So S so plus 2S and then cosine of S squared T. And then for the second part, for partial Z, partial T, first thing is to write the formula. for the chain rule. So we'll have partial z partial t equals to partial z partial x times partial x partial t plus partial z partial y partial y partial t. Partial z partial x will give us, so this one with respect to x is e raised power x sine of y. Partial x partial t will be 2st. Partial z partial y will be e raised power x cosine of y. Partial y partial t will be s squared. And then the next thing is to replace everything by x by st squared, y by s squared t. So it'll be e raised power st squared sine of s squared t. We multiply by 2st plus e raised power st squared cosine of y is s squared t, and then this one you multiply by s squared. So now common here is e raised power st squared and then s. So we can say s e raised power st squared into the first term will be 2t sine of s squared t plus this term will be s and then cosine of s squared t. So that's what we have, 2t sine of s squared t plus s cos of s squared t. So that will be the solution. And then another example given. Given w equals to x squared plus y squared, x equals to r minus s, and y equals to r plus s. Find partial w, partial r, and then number 2, partial w, partial s. So this one, the first thing is write the formula solution. Partial w, partial r will be partial w, partial x, partial r, plus partial w, partial y, partial r. So partial w, partial x is 2x. Partial x, partial r is 1. Partial w, partial y is 2y. Partial y, partial r is given by 1. So this will just be 2x plus 2y, but x is the same as r minus s. Y is r plus s. So this will be 2r minus 2s plus 2r plus 2s. So minus 2s and plus 2s cancels out, so that will remain with 4r. And then the other one will be partial w, partial s equals to partial w, partial x, partial x, partial s, plus partial w, partial y, partial y, partial s. Partial w, partial x is 2x. Partial x, partial s is minus 1. Partial w, partial y from this one is 2y. Partial y, partial s is 1. So you have minus 2x plus 2y. Then you replace minus 2 into x is r minus s plus y is r plus s. So this minus 2r plus 2s plus 2r plus 2s. So this time round now r will cancel out. So this cancels out, so that the answer is 4s. So that is how we solve that problem. So thank you.